Alright, let's derive E equals mc squared in a more difficult fashion using calculus. And for some of you, you've learned some calculus, some of you haven't, some of you find this very difficult. I just thought that I would show it to you. It doesn't take that long. Let's start with f equals ma. Now, if I know calculus, I know that, and rates of change, I know that a is dv by dt, where dv is the change in velocity and dt is the change in time. Yes. So the change in velocity is also equal to vf minus vi. So I would get that f equals m dv dt, which is m vf minus vi over t. Now I'm going to bring this in, and I'm going to get mvf minus mvi dt all over dt. And if we look closely at this, mv is momentum, and so I have final momentum minus initial momentum, which is the change in momentum over time. Yes, but I'm going to leave that as dmv by dt. Oops. So I'm going to use the anytime I take the derivative of two things that are multiplied together, I use the product rule, which is it's the first term times the derivative of the second plus the second term times the derivative of the first. Yes. Now I know that work is force times distance, so if I use a little calculus, so a tiny bit of work must be equal to force times a tiny bit of distance. Let's bring this definition for force right down here. I'm going to get dw equals m dv dt plus v dm dt times dx. Now I'm going to bring in the dx, and I'm going to get m dv dx dt, and yeah, I'm writing it slightly different, but all the terms are there. V dm dx dt. So when I look closely at this, and again I apply some calculus that you may have learned already, dx dt is v. So I get dw equals m dv times v plus v dm times v. And I will just clean that up a bit. I will write it as mv dv. We usually write these d terms last when they're in a time plus v squared dm. And I know work is energy, so I'm just going to write this with an E now. And we'll call this equation number 1. Now we're going to use the relativity formula for mass. Mass is equal to m0 over the square root of 1 minus v squared over c squared. So m0 equals m square root 1 minus b squared over c squared. I'm going to square both sides, so I'm going to get m0 squared equals m squared times 1 minus b squared over c squared. And then I'm going to multiply everything by c squared, so I'm going to get m0 squared c squared equals m squared c squared minus b squared. So now I'm going to take the derivative of both sides. So I need to take the derivative of this side, and I need to take the derivative of this side, and I might as well just expand this in at the same time. So m squared c squared minus m squared v squared. So the rest mass is a constant, c is a constant, the derivative of a constant is 0. Equals. When I take the derivative of this, c squared again is a constant. I don't do anything with that. The derivative of m squared is 2m dm. Now this thing, I'm going to have to use the product rule again. So it's the first term times the derivative of the second, which is 2v dv, plus the second term times the derivative of the first, which is 2m dm. Now I'm going to bring this negative sign in, and I'm going to simplify. I'm going to divide everything by 2m. So I'm going to get 0 equals c squared dm minus mv dv minus v squared dm. These are negative, I'm going to swing them to the other side, and I get c squared dm equals mv dv plus v squared dm. Let's call this equation number 2. Now, equation number 1, if I just scroll up here, said dE is mv dv plus v squared dm. Now, if I compare these two equations right here, mv dv v squared dm, both of these things are equal to this, so therefore these two things are equal to each other. So dE is equal to c squared dm. Now, the opposite of taking the derivative of something is something called integration. I'm going to go the other way, and so therefore I integrate dE equals c squared dm. This means go the other way from being a derivative, and I get E equals c squared is a constant, it's going to be unchanged. What do I have that when I take the derivative of it I get dm? It's just m. So if watch going backwards, if I take the derivative of this with respect to m, I would get c squared dm, and here I would get dE. And therefore I have right here E equals mc squared using calculus.